have a huge opportunity in front of us to not waste so much resource and carbon.
This commercial scale prove out of this technology, it's enabling a whole new stream of recycling.
We are revolutionizing recycling because we are taking things back to the molecular level.
We're targeting the hard-to-recycle waste. With new processes, waste can be seen as raw material with value. We're showing the world that we can do it.
Good afternoon, everyone. It's exciting to be here today. And actually, PRSE has really become a place where the entire recycling and plastics ecosystem is coming together. And that's always resulting in great conversation. And I also realize we're getting close to the end of today, so thanks for sticking around, and I'll do my best to make these next minutes worthwhile and insightful for you all. My name is Camille Stefani, I work for Eastman, and I would like to show you today what happens when molecular recycling meets material innovation. And through concrete partnership examples, I will show you how it moved from a concept to a commercial reality. But I want to start with a question first here. What do all these products have in common? Any thoughts? If I could hear you think, you probably think plastics, right? In fact, these are all polyesters. Might not always be obvious, but these are all polyesters. What else is true about these products? Any thoughts? Recycled plastics, right? These are actually made from hard-to-recycle waste. And in fact, these can be made with up to 100% recycled content, all without impacting how they look, how they feel, how they perform, how safe they are. And you know what I like best about these examples here? They're real products. They are real products thanks to real and strong partnerships. So let me go back a little and show you how we got there. For the people in the room who don't know Eastman, we are a global materials innovation company. We're headquartered in the US. We have a regional office here in Rotterdam and an R&D hub in Ghent. And we're serving customers everywhere around the world with a revenue of about $9 billion. And at Eastman, we define our purpose as enhancing the quality of life in a material way. And in practice, that means that we're focused on 3 areas: mitigating climate change, mainstreaming circularity, and caring for society. And for the people in the room here who know Eastman, you know that we go back more than 100 years, right? Because Eastman was part of the Eastman Kodak company. It was actually founded by George Eastman here, and our company was the division, the chemical manufacturing division, that had to ensure that all the chemicals and all the materials used in photography were readily available. And it's in fact that 100-year history of innovation that still brings us here today, and I'll touch back on that later. So through that history of innovation, polyesters have always been really central to Eastman. In fact, we were one of the largest PET suppliers in the world. And today, we are active in a wide variety of specialty polyester applications. That journey started in the 40s, when Eastman developed specialty monomers that were used in PCT fibers, and they were used in a wide variety of industrial applications. Over time, that development led to PET, and Eastman was one of the first companies to actually commercialize PET for packaging. We kept developing the chemistry, we kept evolving it, leading to a higher heat resistance, better chemical resistance, better mechanical properties, and that led to a diversification of our portfolio of high-performance copolyesters. And this was around the time that the PET market was actually getting commoditized. So Eastman kept innovating. It was around 2007 that we launched Triton, our today flagship product, known for its superior durability, excellent clarity. It's actually BPA-free, catalyzed the whole market trend there. And it's used in many applications that I bet you use today. Your reusable water bottles, your food storage containers, medical appliances, electronic devices, even chocolate molds. in your eyeglasses. It's in many areas. So all the way from these specialty monomers up to PET, we kept improving what polyesters could do. And now we're adding circularity to that. So our continued innovation focus will be on next generation materials, but we're combining that with the power of chemical recycling. We're making our materials perform better, but also make them more sustainable. And we've been busy over the last couple of years, and we've been around here, we've been engaging with many of you. And in fact, we've reached a major milestone because we have built the world's largest molecular recycling facility that is using hard-to-recycle waste. It's operational for more than 2 years already. We've built it in Kingsport at our main integrated production site, and it's integrated with our existing polymer production. And this technology is really showing, in our view, the world what's possible, because it paints a picture of what plastic circularity can look like. But only because it adheres to a few key principles that are very important to us. And I'll name 3. First of all, it's a high-yield, material-to-material recycling process, not producing fuels. The second is, it's fully complementary to mechanical recycling, addressing streams that would otherwise not get recycled. And lastly, it allows us to produce products that have a lower carbon footprint than when we would make them through virgin sources, through virgin routes. So what do we do in practice here? We start with hard-to-recycle polyester waste that couldn't get recycled. We then recycle it, we turn it into new plastics again, and those plastics are used in applications that typically couldn't use any recycled content. So let me say that again here. Waste that wasn't recycled into applications that couldn't yet use any recycled content. And we do this through a process called methanolysis. Quick look on the feedstocks here. We are recycling things like colored bottles, opaque, with fillers, compounds, more complex streams like trays, but also carpet fibers. In fact, we are recycling the waste from mechanical recyclers. And on the product side, we call it renew. So let's take a look what we do in more detail. I bet you're interested in that. So we start with those hard-to-recycle polyester feedstocks. We first go through a mechanical step where we remove some of the contaminants, we remove non-polyesters, and we make the stream more consistent in size. And then we move to the next step, which is the methanolysis process, and that's the backbone of the process where we actually break down this polyester polymer into its 2 main building blocks. And that's DMT and EG. And it's those 2 recycled monomers that we keep purifying until they are indistinguishable from virgin sources. And they make its way into our existing polymer lines. And from there we can make anything ranging from a Triton up to a PET. And the beauty of this process, it's a drop-in solutions for our customers. So customers that are already using our solutions today, they can immediately switch to a recycled version. And there's another beauty to this process, and it has to do with the fact that we were once part of Eastman Kodak. Because methanolysis, in fact, is nothing new. We've had our own methanolysis plant in the 70s and the 80s already. But back then, we were using it to depolymerize polyester film that was used in photography, and we recovered the precious metals that were on there. But the technology here is fundamentally the same. But we kept innovating, we kept improving it, we kept evolving our know-how, and that allowed us to commercialize it at this scale and in an integrated way so that we can now recycle those hard-to-recycle streams that you see here. And I hear some people think, we have mechanical recycling, right? Why do we need molecular? I think it's pretty obvious, and I hope you can follow. Mechanical recycling is a great process. It's a fantastic process. if you can recycle something mechanically, you should. It has the best footprint, it's pretty economically effective, and there's good infrastructure, right, to collect and to sort. But there's a couple limitations. First of all, the mechanical recycling works great for clean bottles, as you know. But that means that all the other polyester that is out there still needs an end-of-life solution. The second is, in those bottle-to-bottle recycling solutions, you always have a degradation with each cycle. And also with each of these steps, you get a yield loss. And that is ultimately limiting how circular PET can get with mechanical alone. And lastly, the rPET from mechanical recycling just doesn't always have the right composition and isn't always the best fit for every application. And that's why we say molecular recycling is there to complement mechanical recycling, and it will address gaps that mechanical leaves. But where do we see those gaps in today's market? Let me show you a couple areas. So first of all, aesthetics, where the color or the clarity or the consistency of rPET might be simply not what the brand wants or might be not good enough for the application. Or design freedom, where the composition of rPET, like I said, is just not a good fit for the more complex designs. Performance and reliability, where the contaminants in the stream, they might actually impact the processability, especially in more demanding applications or applications with a longer shelf life. Safety and quality, because the impurities in the stream, they can over time become a real concern, especially in the more sensitive markets or the regulated markets. And lastly, circularity, where a different end-of-life solution is needed. And I bet you probably recognize some of those trade-offs. I want to show you a couple partnership examples of companies that face such challenges and how we partner with them to overcome those, thanks to molecular recycling. The first one I want to show you is about aesthetics, and that's a partnership with Pencolor. Packaging is really, right, how the consumer interacts with your product, how they feel it, what they think of it. And the impact with rPET is that the color might be more yellow, might be darker, and that's perfectly fine for some applications. But not if your application is all about color and emotions, like in personal care. So thanks to the partnership with Pencolor, a leading color master batch supplier, we are able to offer consistency across all recycled content levels. On the screen here you see two bottles made with the same colorant. One is in PET Renew, very vibrant, true to color, virgin-like color. The other one is made in rPET, and the visual impact is clear. So thanks to a collaboration like this, there's no longer a trade-off between brand equity and sustainability. The next I want to show you is about design freedom, and this is a partnership with Toli. And this compact case is an example of an application where different materials were used and different designs were used that weren't recyclable. So the market was basically at a crossroad. From one side, they want to maintain their premium look and feel, their brand identity. From the other side, they want more sustainability. And the question was, can they have it all? So thanks to this partnership with Toli, the answer is yes. Because we developed a crystal clear, glass-like compact case that can be made with up to 100% recycled content and is recyclable in the existing PET stream. Like I said before, the bottle rPET composition might just not be the right choice for a solution, and that's exactly what we did here. So thanks to this, there's no longer a conflict between the premium look and feel and circularity. The next partnership I want to show you is about performance, and this one is with PepsiCo. PepsiCo and Eastman go way back. In 2022, we signed a long-term supply agreement to help further scale Eastman's circular platform. And we have some exciting news to share now, because Pepsi is rolling out PET Renew for their Gatorade bottles. That's their #1 sports drinks brand in the US. They even wrote an exciting article about it on their own website, highlighting how molecular recycling is helping them achieve their sustainable packaging goals. So in this collaboration, we commercialized a new PET resin that is specifically formulated for hot-fill beverage packaging. And thanks to this, it's now possible to use recycled content in applications that used to rely on virgin PET to be created. And these bottles are hitting the shelf as we speak, so if you're in the US, maybe you have one. Otherwise, come at our booth and check them out yourselves. The next example I will show is about the Nordics, and is a partnership with Dulup. In the Nordics, there is a very efficient, very effective bottle deposit return system. High collection rates, a lot of rPET being used, but that success is actually revealing a challenge, because over time, in this closed-loop system, the quality goes down, and it's becoming so bad that the color and the processability of the stream is being impacted. And as a result, some of these markets have said, hey, we will put the limit to 80% of how much rPET you can use. And the other 20%, they can come from virgin sources or virgin-like sources, like molecular recycling. So this is something we address with Dulup, a leading bottle supplier in the space of beverage bottles. And we are combining the best of both worlds now in one bottle. Mechanical recycling is the basis, but we're adding molecular recycling to it to maintain the stream purity and the long-term safety for that system. So with brands adopting a solution like this, there's no more compromise on the long-term circularity of that system. And I will show you 2 more partnerships now. Both are about circularity. And this first one here is with P&G. So thanks to molecular recycling, it is now possible to provide an end of life for products and materials that would otherwise end up as waste. And this really resonated with P&G. So we partnered on an agreement, both on packaging innovation like you see here, but also recycling infrastructure initiatives in the US, to make sure that more waste, more materials get collected, and there's better infrastructure in place to bring them back in the loop. And the Herbal Essence bottle that you see here is actually the first adoption by P&G. And it's thanks to this adoption that they're able to reduce their virgin consumption, but also maintain their sustainable brand image that they have for this product. And the last example I will show you is about the automotive industry. And this is a partnership together with Fisher Carvelli and Volkswagen. And this industry, they relied on packaging waste, just like many other industries, to meet their sustainability goals. But this is no longer accepted, right? If you paid attention, the End-of-Life Vehicle Directive is saying that a part of the plastics in the car should now come from closed-loop automotive waste. And that's really a challenge with mechanical recycling. So we partnered with Fisher Carvelli and Volkswagen, and we designed a monomaterial PET floor mat for cars. And we worked through two aspects here. First of all, a redesign so that we go from a multi-layer material, a multi-material solution, to a monomaterial solution. And that will enable end-of-life through chemical recycling. But also, we qualified a PET Renew fiber grade that is used in the carpet. And this is an example where mechanical was not enough from an end-of-life, but also a beginning of life. Because using bottle rPET in this application was actually pretty complex. So you wouldn't be able to meet the performance requirements or the visual appearance or the consistency. But thanks to molecular recycling, they are now possible to improve both their performance and their sustainability. And I think the pattern across all of these is quite the same. Brands want more circularity, but they don't want to compromise. And in many of these scenarios, Eastman Renew is not just a material. It's an enabler for better product design, better performance, and true circular outcomes. And while I wrap up, I want to recognize the companies behind these examples, because today's market is tough, right? But these companies, they decided to take action. They decided to move early, work through all the complexity to make real progress happen. And that's why partnership matters, because innovation does not happen in isolation, and certainly not in a circular economy. So if you're a brand or a retailer, a producer, you name it, you recognize some of these challenges and you want to take action, we at Eastman are your partner. We are here at the booth. You can simply check out the website if you want to learn more, but we would be very excited to partner with you and figure out what that next partnership could look like. Thanks for your attention. I heard we have an app for questions with the Slido, so you can upload them, and I don't know how I'm doing with time, but I'll see if I can cover a couple. Hello, you mentioned an eyeshadow box compatible with PT recycling. If correctly collected, in which stream would it end up? It will probably not be sorted in PT bottles nor PT thermoform streams, right? So that's the example that I showed, right? The compact case that is made with a glass-like PET. It is a PET, and is actually it actually received the recyclability certificates from the different authorities. I think top of mind here, right? What is that? Recyclass and EPBP, even APR in the US. So this is a material that enables unique designs, but it's compatible with the existing PET recycling stream. So it could be recycled alongside the PET bottles. That's the value proposition for that material, that you get that end of life alongside, well, basically in the existing PET stream. Any news from the Eastman plant in France? When will this be operational? So our first plant is operational, right? You saw that. Eastman has been working on additional projects over the last couple of years. France is one of them. We had another project in the US. And the project in France, it's tomorrow morning, our managing director for France will have a talk. He will talk about it probably, but it's ready. The project, in theory, on paper, is ready. We've secured feedstock partnerships. We've secured the land, right? We picked a site in Normandy. We got all the permits to build and to operate. And we got subsidies, a lot of support from the French government. But the situation around the policy, but also the market conditions, right, aren't where it needs to be to make a final investment decision. So we continue working on it, we continue advocating, but we need the market to be ready as well. So partnerships matter, right? These things aren't built on their own. So if you have thoughts, please visit us, and hopefully we can take a step together. I didn't see any more questions come in. Let me see if that's correct. Are you looking in PT glycolysis, as you mentioned some years ago at PetCore conference? So Eastman uses a methanolysis process, right? I explained that. We did use some glycolysis as well in the past, but today we are focused on methanolysis, because this offers us the robust feedstock strategy that we show here, right? Addressing really waste that couldn't be recycled. And thanks to methanolysis, we get a very strong molecular purification that really makes those products virgin quality again. So that's important for Eastman and the choice for methanolysis today. But obviously, we have a 100-year history in polyester innovation. So I'm not involved there, right? But we have teams looking into all solutions that are needed to address the waste challenge. What's the capacity of the French plant? And who are your off-taker, source of methanol? It's a couple of questions, it seems. Well, the methanol stays in a closed loop in our system. So we use it to depolymerize, and we recover it when we make the products again. And the capacity of the plant is going to be similar to what we already commercialized in the US. So roughly 110,000 tons capacity of polyester waste that can be recycled and turned into new products again. The off-takers, well, we have some exciting examples at the booth, right? Eastman is active in a wide variety of specialty polyesters, ranging from Triton to cosmetics to food and beverage packaging or consumer health. So among those will be off-takers, right, that would really benefit from a plant like that in France. We have actually, like I said, the great partnership with Pepsi. That is helping us further scale that platform in the US. So it's partnerships like that we're looking for to be able to further scale also the French plant. My connection is not private. Let's see. Does that mean we're out of time and out of questions? Any more questions in the room? Because I'm not getting them here. If not, I want to thank you. Thanks for staying here with us to the end of the day here. We have an exciting next session coming up as well with some cross-company engagement, including a speaker from Eastman. So stick around if you're interested in that. And otherwise, I'll be here. I see a lot of friendly Eastman faces here, so come have a chat or come to our booth and we can continue the conversation. Thank you.
We have a huge opportunity in front of us to not waste so much resource and carbon.
This commercial scale prove-out of this technology, it's enabling a whole new stream of recycling.
We are revolutionizing recycling because we are taking things back to the molecular level.
We're targeting the hard-to-recycle waste. With new processes, waste can be seen as raw material with value. We're showing the world that we can do it.